Hey everybody, this is the conclusion of the lesson on finding the estimation of the population mean mu, and this is kind of going in reverse, just like we went in reverse with the population proportion. We know that the part of the expression that is after the plus or minus sign in a confidence interval is the error, and in that case we had error is equal to t, but because we want it to be sort of the ideal, we're going to go back to our z table, and that would be times the sample standard deviation over the square root of n. Now the part that's in here is just math, so I'm just going to work through it so you can see how I get the formula. I need to solve this for n, so the first thing I did was multiply both sides by the square root of n. Alright, and then I divided both sides by e so I could get the n term by itself. And how do you undo a square root? Well, you square both sides. So when I squared both sides, this comes out just as n, and this side comes out as being squared. Alright, so that leads me to the formula for finding n if I'm looking up a population mean. Alright, it says the sample size required to estimate the population mean mu with a level of confidence 1 minus alpha times 100% with a specified margin of error E is given by n equals z alpha over 2 times s, the sample standard deviation, divided by the error squared. And remember that you're going to round up to the next whole number. Alright, so let's do an example. An athletic trainer wants to estimate the mean amount of days needed to recover from a meniscus tear in the knee for female patients aged 50 to 60. How many subjects are needed to estimate the mean recovery time within 3 days? Alright, so it is telling me within 3 days. That is my error that I'm allowing myself. With 97% confidence. Alright, so that's my confidence level, and my standard deviation is assumed to be 12.3 days. Okay, so you're going to have to flip back to the other table, the standard normal table. Alright, so we want to do 97% confidence. So that says we want to be 97% confident that it is between the lower bound and upper bound, which means we're going to allow ourselves 3% error, split evenly. Says that each tail would get 0.015. And we know when we look up in the standard normal table that it's always, for the table we have, it's always good to have that area in the left tail. Alright, so I'm going to look for the area that is closest to 0.015. And let's see, 0.015 is somewhere. Well, look there. It is exactly there. And that is the value negative 2.17. Alright, so we're going to do 2.17 for our z alpha over 2 value. So now I can just plug it in the formula. We know that n is equal to our z alpha over 2 value times our s divided by our error squared. So we're going to have 2.17 times the standard deviation 12.3 divided by 3 squared. Alright, and if I put that in the calculator, I get 2.17 times 12.3 divided by 3, and we want to square that. And we get a value of 79.16. So 79.16, we know we're going to round up to the next whole number. So even though that is 0.16, this is going to get rounded up to 80. So we need a sample size of 80 in order to be 97% confident that the population mean will be within 3 days of the true population mean. And that is how you find minimum sample size. Thanks, guys.